Okay, so in today's session, I'm going to be covering hypothesis testing. So I'm going to do this by going through an example. We'll share my whiteboard. All right, so the example, I'm going to try and go over two examples from your textbook to kind of illustrate how to work through hypothesis testing problems. The first question I'll work through is on page 245 of your textbook, and it's exercise 7. So I pasted the question here on the whiteboard for reference. So if you read the question, it says the manager of a large shopping mall in Eisner believes that visitors to the mall spend on average 85 minutes in a mall on any one occasion. Now, to test this belief or this claim of the manager commissions a study which found that from a random sample of 132 visitors to the mall, the average visiting time was 80.5 minutes. Assume the population standard deviation of 25 minutes and that visiting time is approximately normally distributed. All right, so the first question says, formulate the null and alternative hypothesis for this test situation. Now, in hypothesis testing, so I'm going to use my stylus, and here we go. Right. So in hypothesis testing, your first step is to declare the null and alternative hypothesis. So that means declaring your H0, that's your null hypothesis, and then your H1, which is your alternative hypothesis. So this is your step 1. So I'm just going to write S1 here so that you know it's your step 1. All right. Now, in this problem, if you look at it, we're talking about averages. Okay. You can see the question is talking about averages. So that means we're going to be referring to the symbol mu. Okay, and as you should know by now, mu is the population average. All right. So now what you need to know for H0 is that H0 will take any of these three symbols. It will take an equals to, it can take a greater than equals to, or it can take a less than equal to. All right. And your H1 will be the opposite of those, which means if you had an equals to for H0, then you'd have a not equals to for H1. If you have a greater than equal to, then you must have a less than. And if you have a less than equal to for your H0, then you would have a greater than. Okay. Now what we need to determine is which of these three symbols are we going to use for H0. And that boils down to reading the question. Now, you got to try and gather from the information whether we're just trying to test whether it is that value or not, or whether it's greater than or whether it's less than. And you can, if you read the text, it's basically just checking whether they do spend an average of 85 minutes, and that's it. There's nothing about it being greater than or less than or at most. It's simply just equals to 85 minutes or not. So that means we're going to use this equals to, the first option, equals to, and remember the claim is the manager believes it's 85 minutes, so that's what we test. We test the claim. And then the opposite of the equals to will be not equals to. All right, I'm going to erase this part here. Now that we're established the symbols, and here. Now I like to make a note on either H0 or H1 to see which one is the claim. Now if you read the text, it says the manager believes that they spend on average 85 minutes. So that means this is the manager's claim, H0. This is what the manager believes. I'm going to write manager's claim. Now when it's an equals to, like what we have here, and a not equals to, that means it's a two-tailed test. Okay, so remember that. So this is a two-tailed test, and I'll show you what that means visually. This is a two-tailed test. All right, so that is your question A done. For question B, all right, it asks for what test statistic, Z or T, is appropriate and why. So for question B, what you need to know is when you know sigma, that is your population standard deviation, and in this problem, it says the population standard deviation of 25 minutes. So it's telling you that your sigma is 25. So when you know sigma, right, it'll generally be a Z statistic. That's a key giveaway. The other giveaway is that your sample size must be bigger than 30. And if you look at the question, it says a random sample of 132 visitors. So that's way bigger than 30. So your n here in this case is 132. So because your sigma is known, right? So I'm just going to write your sigma is known and your n is greater than 30. That means we will use a Z statistic. So it's a Z stat. If your sigma is unknown and your n is smaller than 30, then you use a T stat. Okay, so it's the opposite. All right, so that's question B. All right, so we're going to use a Z statistic. Now, for question C, it says conduct a hypothesis test for a single mean at a 5% level of significance to support or refute the manager's belief. Right, and then draw a conclusion basically. So for C, right, now we're going to answer question C, which is a bit of a long step, which is most of the marks for this question. Right. We're going to test this hypothesis, and what we need to do is proceed from where we left off on step 1. So step 1 is declare the null and alternative hypothesis. Step 2, which I'm going to write as S2, we're going to find the critical value. So in other words, the acceptance and rejection regions. Now, this is why that part where I wrote it's a two-tailed test is going to be important. Now we know we're dealing with a Z statistic. So I'm going to draw a Z curve as best as I can freehand. Okay, so this is our Z axis, and the Z, or the standard normal distribution curve, is centered at 0. Now when we say two-tailed test, that means there's two rejection regions. There's one on the left here, and then there's one on the right. They both have the same area. And that area is basically what it depends on your level of significance. And if you read question C, your level of significance is 5%. In other words, the symbol for level of significance is 5%. So I'm going to write, you can either write 5% or you can write 0.05 as a decimal. Now because you got two rejection regions, that means you have to split this alpha into two equal parts. So you divide it by 2. So in other words, here you would have 0.025 because I'm dividing 0.05 by 2, and then here I'll also have 0.025 because it's a two-tailed test. Now the next part for step 2 is to determine what is the value on the Z-axis here. I'm going to put that in a different color, maybe green. Right, so basically try and find these values at the boundary, right, where your area, where that shaded area starts. Now the thing is, from the previous learning units, we've covered how to calculate the area under this curve when you want to work at probabilities. Now you're going to do the opposite. Now you're going to be given this area. Now we can work out this area from 0 to that blue shaded area. So I'm going to put this area in green here. This area we know because half this area, that means the area from the vertical line of 0 all the way to the end on the right, is 50%. Because remember, and I've covered in the previous video, the total area is 100%, or in other words, 1 under this curve. At 0, we split the area in half. So you got 50% on the right and 50% on the left. But the thing is, you've already got some of this blue area being used here. That's 0.025. So the remainder of this green is 0.5 minus this here. That means you're left at 0.475. All right. Now that we know this green area, we can go to our table in our book or formula sheet, and you can find this critical value. Right. So if you know the area from 0 to that Z point, you can get that Z value. So if I go to textbook here, I'm going to go to the curve, which is towards the end. Oops. Give me a second. Too far. There we go. So remember, the area is 0.475. So all we got to do is look in this table for where we find the closest value to 0.475. And it's somewhere around here, 0.475. So the value, your Z value is 1.9, and it matches up with 6 on the top here. 1.96. Okay. So I'm going to mark that value on the axis here. That's 1.96. So the value on the left is the exact same thing, but it's the negative value because this graph is symmetric. So negative 1.96. So what that means is the blue area is where you reject your H naught, and everything in between it is where you accept your H naught. So from here to positive 1.96, we accept H naught. And everything on the right, I'm going to put it as a different color, maybe red. Everything on the right, we reject H naught. And then everything on the left of minus 1.96, we will reject H naught. So this is step 2, okay? Finding your acceptance and your rejection regions. All right, now step 3 is a bit more of calculation. Okay, so I'm going to go back to my colors. Blue. All right, so now we're done with step 1 and step 2. Let's go to step 3. Step 3 is calculate the test stat. Now the formula for your test statistic is in your formula sheet. You don't need to memorize it. Remember what we said in question B. We said we're going to be using the Z stat. So that means we need to use this formula. Z equals to X bar minus mu all over sigma over square root n. Now, all we need to do is plug the values into this formula. Now the value for X bar is given in the text. If you read there, you took a sample of 132 visitors, and the average of that sample is 80.5. So that's your X bar. So I'm just going to put a note here. Your X bar is equal to 80.5. So now we have X bar. Your mu is what's declared in your null hypothesis here. So your mu is 85. Mu equals 85. And your sigma, as we know, it's given, it's 25. Your n is 132. So you plug all the values into this formula, right? You plug all those values in and you get a value of minus 2.068. Right, and that's step 3. You've calculated the test statistic. Step 4 is very, very simple. All right, I'm going to erase everything on the left here, so I've got some space to write. Won't need this now. So there's only 5 steps, so don't get intimidated or lose hope. There'll be 2 more steps which are done very quickly now. All the hard work is actually done. All right, so now we've done step 3. Step 4 is basically looking at what you got in step 3 and deciding whether you reject or accept your H naught. All you need to do is look at the value that you found in step 3. And in our case, we got a value of minus 2.068. And you just got to check in which region does it lie in. Does it lie in the red line? Does it lie within the green area part? Or does it lie in the far right red part? Now, everything from minus 1.96 to positive 1.96, we would accept H naught. The value we got is minus 2.068. So that means minus 2 is further to the left of minus 1.96. So that's somewhere around here. It doesn't have to be exact. All you need to know is, does it lie in the rejection or acceptance region? And you can see it's going to be further to the left of minus 1.9, right? Because you think of this line here, the Z line, as a number line, okay, which goes from negative infinity all the way to positive infinity. and you're going to find out where does this value sit on that number line, and it's going to be somewhere around here. Okay, all we know is that it's on the left of minus 1.96, so it's falling in here, so it means we reject our H naught. We'll just put this statement here. Right, and then the last step, step 5, is writing it out in words, and I'm going to use text here. All right, so the thing is, we know we reject H naught, so when we say we reject H naught, I'm just going to put an X here. That means I reject H naught's claim. That means I reject the manager's claim, and that's why I wrote this here next to it, so that it makes my last step very easy. So that I know that because I'm not accepting H naught, I'm rejecting H naught. That means I'm rejecting the manager's claim. So I'm gonna write this in text. And when you do step 5, always start or make sure you mention at some point the level of significance. Okay, it's very important that you mention the level of significance. So I'll start off by saying at a 5% level of significance, right? Right. The data shows statistical. I'm gonna make this a bit larger in a second. Shows statistical evidence that. Okay. Data shows statistical evidence that visitors do not spend on average, and that's because we're rejecting H of the that they do spend 85 minutes, because we got mu equals to 85. So I'm actually accepting H1, right? So the visitors do not spend on average, do not spend 85, sorry, do not spend 85 minutes on average at the mall, right? The manager's claim is false. Hence, the manager's claim is false. And this is how you would need to conclude, okay? Write it out like this. Don't just say reject H1 and leave it like that. You got to answer it in terms of the problem, all right? And that's how you would answer this question, question C. So this is around about a 10-mark question. So please spend some time working on it. It's not a difficult question. You just got to follow the steps, and eventually you get to the answer in the end, right? So just walk through more problems. I encourage you to walk through this problem specifically so that you you have an answer and you actually have the working to kind of look at for reference. All right, so let's walk through another problem, and now I'm going to walk through question 16 in the same chapter in your textbook. That's page 248. I'm just going to create a new one. And insert the question here so you have it for reference. All right, here we go. So here, a motor vehicle insurance advisor stated recently in a newspaper report that more than 60% of K-Town motorists do not have a motor vehicle insurance. So I'm just going to underline this part here. Okay, so I'm going to maybe use this. Okay, they say do not. Here we go. Good enough. All right. Okay. A random survey amongst 150 motorists found that 54 do have motor vehicle insurance. So there, the claim is in terms of how many do not have vehicle insurance, but the data tells you how many do have insurance. So just keep that in mind, right? That's going to create a bit of trickiness to this problem, which is why I underlined that part in blue. Now, question A, is the motor vehicle insurance advisor's claim valid? Formulate the null and alternative hypothesis and conduct the hypothesis test for a single proportion. So now we're dealing with proportion. Now we're dealing with pi, not mu. So we'll have our H naught and we'll have our H1. Now it's very important if you look at it, says in the text, it's even highlighted in italics, or say, but in your exam it won't be highlighted. You need to figure it out. Okay, it says more than 60%, and this is key. So more than is this symbol here. Right? Remember what I told you in the earlier part of this collab, when you work through the previous problem. The greater than sign will always fall in here, right? For the top, you can either have less than equal to, or you can have greater than equal to for H naught. So because that part says more than 60%, that's going to be here. So 0.6, you can write 60% or you can write 0.6, and we're talking about pi. Now because we have this for H1, the opposite of greater than is going to be less than equals to 0.6. All right, that's what we're testing. So that's our null and alternative hypothesis. This is a one-tailed test. One-tailed test. Now you need to identify whether it's an upper or lower tail test. Now this is how I do it, how I identify it. For me, it just works out really easy, but I leave it to you to figure out what works for you. Okay, for me, the symbol in H1, I think of it as an arrowhead. So because I'm talking about greater than, this looks like the head of an arrow. So that points to where the rejection region is. So for me, I can tell from that arrow that the rejection region, just like before we had that Z curve, the arrow points to the right, so that means the rejection region is here on the right. So it's an upper tail test. So if it's on the right, it's an upper tail test. If it's on the left, it's on the bottom, then it's a lower tail test. So it's a one tail test, and specifically it's upper tailed. Please make sure you include this when you state your null and alternative hypothesis, right? You get marked for that. Okay, right. Now, as before, I like to write whether it's H0 or H1 that contains the claim. Now, in this case, we have a insurance advisor that's making a claim, and the advisor claims that it's more than 60%. So this is where the advisor's claim is. It sits here. This is the advisor's claim. All right, that's step one done. Now let's go to step two. I've already started drawing the curve here. So this is step two, right? It's finding the rejection and acceptance region. Now because it's an upper tail test and it's one tail, that means the entire alpha, or the level of significance, gets allocated to this area. In our problem, the alpha is 0.05, so the entire 0.05 goes here. There's no need to split it because there is only one rejection region, which is in the upper tail of the test. So that's your 0.05. So just like before, when you're talking about proportions, it'll always be a Z curve that is centered at 0. Now we need to figure out what is this value here at the critical point. Now, just like I did before, you need to use the table in the book or in your formula sheet to get this value. Remember, the table will always give you the area from 0 to that point. So that means you need to know what this area is in green. And that's pretty easy to do because remember what I told you, half the area is 0.5 and you're already using a 0.05 for the blue region. So this region here is just 0.5 minus 0.05 and you're left with 0.495. So that point, wait, give me a second. 0.5 minus 0.05. I just want to check my calculation here, please. Should be 0.45. Should be 0.45. Minus 0.05. Yeah, 0.45. Yeah. Sorry. Change this. 0.45. Okay, so this green area is 0.45. So we would look in our table, we would look for the area of 0.45, which is somewhere, it's in between these two, right? There isn't an exact 0.45, it's in between these two. So the rejection region is 1.6 here, 1.6, and it's actually 1.645. It's halfway between these two, but we'll just round it and make it 1.65. Okay, so the value here is 1.65, right? So everything is everything on the right of it, right? We reject H naught because that's where the rejection region is, and everything on the left of it, we accept H naught. Okay, so that's step 2 done. All right, now step 3. So let me change the color back to blue. All right, so now we're back to step 3, is compute the test stat. Now for proportions, the Z stat is this formula. It's P minus pi all over square root pi into 1 minus pi all over n. And everything in the denominator is under the square root sign. Okay, everything in the denominator. Now we know what pi is. Pi is always given to you in your H0 statement. So it's 0.6. So we'll use pi equals to 0.6, right? N we know. If you read the text, it says 150 motorists, right? That's the sample size. Now we need to figure out what is P. Now remember, we're talking about the percent that do not have insurance, okay? But they tell us that 54 out of the 150 do have insurance. So we need to know what percent actually don't have. So it's the remainder, okay? So your P is actually the number that don't have insurance. So it's 150 minus 54 all over the total, which is 150, and you get a value of, I believe it is 0.64. Okay, 0.64. So there we go. We have our P. Okay, we have a P value, we have the N value, we have the pi value, and we just plug it into this equation. You plug all those values in, and you'll get a value of exactly 1. This works out. It's just coincidental that it works out to such a perfect value. Okay, so your Z value is 1. That's your step 3 done. And now remember, step 4 is pretty easy. It's looking at what you found in step 3 here and checking where it lies in your diagram. Now, 1 is less than 1.65, so it's somewhere around here. It's definitely greater than 0, but it's less than 1.65, so it's around here. Right? It's here. So that means it falls in the acceptance region. So that means we accept H naught. Okay, we accept H naught. Right, and then the last step is just writing it in words. Okay, and that's what we're going to do here. It's please work on the statement. It's really not difficult. Okay, you've done all the hard work, so just try and finish it up with the statement here. So in step 5, we're going to write the statement. Sorry, there. Okay. Remember what we do. We always start with the level of significance. So we say at 2. Okay, so we always start with the level of significance. So in our case, the level of significance is alpha equals 0.05, so it's 5%. So at a 5% level of significance, right? Here, so we can see it, 5% of significance. The data shows statistical. You can kind of use what I have here as a template. Okay, you just got to change it up depending on the problem if you want. The data shows statistical evidence to support, and remember we're accepting H naught, so we're saying it supports H naught, support H naught. Right, that is, and what is H naught? We're saying that the percent that do not have insurance is less than or equal to 60%. So that is less, we'll say most, okay? Less than equal to means at most, okay? Nothing more than that. So we said that is at most 60% of motorists, right, do not have a vehicle insurance. And remember, because we're in favor of accepting H0, the advisor's claim is actually H1. So that means it disproves the advisor's claim. Okay, so we can say the advisor's claim is false. That's why I always like to write in step 1 where the claim is. So it makes it really easy in the end to conclude. All right, so you read this out. At a 5% level of significance, the data shows statistical evidence to support H0, that because we are accepting H0. And what is H0? Well, H0 is saying that at most 60% of motorists do not have vehicle insurance. Or you can also write it as less than or equal to 60, sorry, you could just say motorists that do not have insurance will not exceed 60%. Right? It's up to you, but for me, this is kind of like the most efficient way to write it. And you're saying that the advisor's claim is false. Okay. All right, and that's it from me. Please go to this, and I hope this helps you with hypothesis testing. And that's it from my side. Have a good one, everyone.